Hello, this is Jack Jackson. We're going to be looking at parametric graphing today. So in parametric graphing, what we do is we specify x and y both as functions of a third variable, a parameter we'll use t for that. And what we do is we specify some domain for t, and as t goes across that domain, it varies within that domain, then every t value produces an x and a y coordinate. So basically, in terms of a table, we would have a table of t values which then generate both x and y values. Then you just plot the ordered pairs of the x and y values. Okay? So let's take a look at it on this example here. So here we have two functions. Now, unfortunately, the way Geometers Sketchpad works, it requires us to put an x for the input here. But really, these little x's right here, the little x's in this highlighted portion here should be actually t's. So this should be 3 times t plus 4 and 4 times t plus 2. And we're going to let t go from 0 to 1. Right at the moment, t is 0. And let's plug these values in, and you'll see here the x and y points there. So if we let t be 0, we get 3 times 0 is 0 plus 4 is 4, so x is 4. 4 times 0 is 0 plus 2 is 2, so y is 2. So we're at the point 4, 2, which is where the yellow point is now. Now let's move the t over a little bit, and let's go up to, say, point 1. As we go to point 1, we could plug it in here and get an x and y for that. So if we put in 3 times 0.1 plus 4, that's 4.3. And 4 times 0.1 plus 2 is 2.4. And so forth as we go across here. Watch the point on the yellow point. And I've got it set so that it traces. And so actually in this particular example, it traces from this end, the lower left, to the upper right. And we're tracing out a path, basically a path of a straight line segment. And so this is our actual graph, and I can hit this right here to show this graph. Now, in general, one specific example that we can look at is a line segment. And if we have parametric equations in the form of x of t equals delta x times t plus x sub 0, and y of t equals delta y times t plus y sub 0, then notice if you plug in 0, this first part goes away, and it starts at the point x sub 0, y sub 0. And then if you plug in t equals 1, we get x plus delta x for the x coordinate, and y plus delta y for the y coordinate. That shows you, so if we let t go from 0 to 1, we trace a line segment from that point to that point. So that's what we have here in our example. Delta x is 3, and, well, let's start with x sub 0, y sub 0. X sub 0 is 4, y sub 0 is 2, so it starts when t is 0 right here at this end at the point 4, 2. And then we have, so we're here at 4, 2. And then when we go to t equals 1, the delta x is 3, so from 4 we go to the right 3. Okay? And delta y is 4, so we go to the up 4 from a y value of 2, so that ends up at the point 7, 6 that you see right here. And the path, if these are linear functions like that, remember a linear function is like y equals mx plus b. So here the m is not really the slope of this line segment, but actually just the delta x. And here the coefficient of the x is the delta, coefficient of the t that should be, is the delta y. And of course, if you divide the 4 by the 3, you'll get the slope of this line being delta y over delta x. Or the tangent, that would also, of course, be the tangent of the angle it makes with the horizontal. So there's an example of a parametric equation. Let's try another one here. We'll still go to 0, 1, and let's change this to be 2x plus 5. And let's change this to negative 3x plus 4. Okay, now notice I've still got that yellow showing, so let's get rid of that. Let's go to Display, Erase Traces, and we can erase that. Now we can see that yellow point tracing from one end of this to the other, and see that it traces that line. Now notice again, as we go, we start at the point 5,4, and we end up going 2 to the right and 3 down, so it goes right 2 and 3 down. And so we end up at the point 5 plus 2, which is 7, and 4 plus negative 3, which is 1. So in other words, 7, 1 is the terminal point there. Okay. If I change the formula somewhat, we might not get a line anymore. Let's change this to x squared and see what happens. Actually, it turns out, notice it's still from 0 to 1. It still goes from, the endpoints didn't change, but now it goes in a curved path there. And so again, let's erase our traces, and we can see that that point traces out a curved path. And we could stop anywhere along here with a particular x, let's say a particular t value, let's say 0.5, and we can plug this in here and get the x and y that go with that. Okay, so if it's a half, 1/2 square is 1/4 times 2 is 1/2, plus 5 is 5.5 for the x. 1/2 of negative 3 is negative 1.5, plus 4 is 2.5, so it should be, may not be exactly a 0.5, but that's approximately, should be, if this was exactly 0.5 for t, that should be exactly 5.5 for x and exactly 2.5 for y. And so we can see how that's graphed. And we can experiment with this. If I change this, it's going to trace the same path, but it's going to, if I keep going, it needs to trace it out further. Now the problem is, with this curve here, it's not going all the way. So let me show you how to fix that real fast. Let me leave the traces. Right click on the curve itself, the purple curve, and go to Properties, and then go to Plot. And this says we're only going from t equals 0 to 1. And if I change it to whatever that is there, 2, then that will go the whole way, and we get that entire piece as we go across now. And so we can specify the t values by right-clicking on the curve and changing those properties right there. And I have it where it's graphing the two endpoints kind of separately from that. Okay? And so that gives you an idea of how to do parametric graphing. You can change these to all kinds of things. So let's see, for example, what if I change this to cosine of x, cosine of t it should say, 2 cosine of t, and y to be 3 sine of t. Okay, and let's take away our traces, and let's start with 0. Okay, so let's go, probably this is going to, remember both cosine and sine have period pi, so if we would just go 0 to 2 pi, so if I go to 2 pi, I just type 2p in the box, now it goes from 0 to 2 pi, let's see what happens as we trace our point out. And it looks like what we're doing is we're tracing a little piece right there. If we went to 4 pi, let's see what happens. It's going to trace out further. You know what? I bet we're not in radian mode. Let me fix that. Yep, radian mode. There we go. This is going to look more like it. So if I go 0 to 2 pi, alright, let's see what happens. So as I trace around, look what happens. So notice when we get to here, we're actually at pi, and here we're all the way here around. Well, look what we got. We get a nice little ellipse. And if we want to get the whole thing to graph, remember what I told you to do? Click on the curve there, go to Properties, and we want to go to 2 pi here, and that will graph the whole thing. Notice if we go to 4 pi, from 0 to 4 pi, then in fact what happens is, let's erase our traces, we start here and we trace all the way around by the time we get to 2 pi, but then from 2 pi to 4 pi we just trace around the same points. So we're tracing around all those points twice. Okay? And so that's an example here. And by the way, notice what happened here on this particular one. 3 was how far we went out vertically, and 2 is how far we went out horizontally. We know that x is going to go between -2 and 2, and we know y is going to go between -3 and 3. And we actually get an ellipse there. So there's all kinds of different types of graphs that you could look at, but what we want to get here is just the basic idea of how we do this parametric graphing.